questions of topic momentum, starting with the first question. Figure 2.1 shows an athlete crossing the finishing line in a race. As she crosses the finishing line, her speed is, let's highlight the important points. Its speed will be 10.0 meter per second down to the speed of 4 meter per second. So we have initial speed and we have final speed. The mass of the athlete is 71 kg. Calculate the impulse applied to her as she slow down. So impulse we know is simply is change in momentum. Okay, change in momentum is mass multiplied by final velocity minus mass multiplied by initial. It's basically a change in momentum. So mass is given, that is 71. Final velocity was this, it's 4, and mass 71, initial velocity was 10. So solving this we get 430, it's negative 430 Newton per second. Okay, this is the final answer. Okay, in the B part, define impulse in terms of force and momentum. So you can simply write down the equation. Impulse is product of force and time. Second part, the athlete take 1.2 seconds. You have time to slow down from a speed of 10 to 4 meter per second. Calculate the average resultant force. Okay, so we know that impulse is equals to change in momentum, that is equals to F into T. So we can use delta P is equals to F into T. So F can be written as delta P over delta P over T. Delta P was calculated earlier, it was 4, delta P was 430. So 430 divided by the time is given, it's 1.2 seconds. So it will give you 430 divided by 1.2 is 360 Newton. Okay, in part C, calculate the force required to give a mass of 71 kg and acceleration of 6.4. So simply you have to use Newton's second law. F is equals to ma, mass is 71, acceleration is 6.4. So multiplying both of that we get 450 Newton. So 450 Newton is the answer. Okay, let's move to the question number 2. A figure shows a train. The total mass of the train and the passenger is 750,000 kg. The train is traveling at a speed of 84. The driver applies the brakes and then the train take 80 seconds to slow down at the speed of 42. Calculate the impulse. So again, using the same relation, impulse is equals to change in momentum. Change in momentum is mv minus mu. Mass is given, that is 750,000, and final velocity is 42 minus 7, initial velocity was 84. Okay, subtracting we get 3.2 10 raised to power 7 Newton second. Okay, that will be answer. Okay, in question 2b, calculate the average force result applied to the train. Okay, so for the force, again same relation that we have used in the first question, it's change in momentum divided by time. Change in momentum is already calculated, that is 3.2 10 raised to power 7 divided by time is 80. Dividing both of them we get 4.0 10 raised to power 5 Newton. Okay, in part C, suggest how the shape of the train helps it to travel at a high speed. Okay, it is designed to reduce the air resistance experienced by train. Okay, so the design of train, that is a streamlined design, reduce the air resistance. In part D, the train took 80 seconds to reduce its speed from 84 to 42. So explain why with the same braking force the train take more than 80 seconds to reduce from okay, if we see the first and the second scenario, the difference is same, that is 42 meter per second. Okay, but when it goes from 84 to 42 it will take 80 seconds, but from 42 to 0 it will take less time. Okay, we have to explain the reason. Because at lower speed train will experience less drag, train will experience less air resistance, so it will take more time to stop. Okay, so in part E, on a wet day the train travel a great distance before it stop along the same track. The train has a speed of 84 second before the brakes are applied. Suggest a reason for this. Okay, for on a wet day, due to the moisture, there will be a less friction between the track and the tires of the train. Okay, so on train has the same speed, travel greater distance because there will be less friction on track. Okay, and question 3a shows two railway track A and B traveling toward each other on the same railway line with which is straight and horizontal. The tracks are involved in collision. They join when they collide and move together. Okay, after collision they are moving together. Mass of the truck A is given, mass of the truck B is also given. Okay, and before colliding, mass of this is given, A and B is also given. We have to calculate the speed of the joint train immediately after the collision. Okay, so we have MA, we have MB. We can say its initial velocity of A, we can say initial velocity of B. So writing down the law of conservation of momentum, it is MAUA plus MBUB is equals to MAVA plus MBVB, and we know that VA is equals to VB, that can be simply written as V, because after colliding they both have the same speed. Okay, there is another trick. If you see, the train A is moving toward the right side and B is moving toward the left side. So if the one of the initial velocity is negative, the B initial velocity of B will be taken as negative. Okay, so putting the values, because they are in opposite direction, momentum is a vector quantity. Whenever the directions are opposite, the sign will be reversed. Okay, so substituting the value, we get for MA it is 2700 multiplied by 3.6 plus 22000 multiplied minus 2.4 is equals to, we can take this VA and VB are same, so we can simply write them as, we can simply write V and V can be taken as common. Okay, so V is MA plus MB, and by writing this we can simply put their values there. MA is 2700 plus 27,000 and 22,000. Okay, so what we have to find, we have to find this V. So this whole term will go on the left side and it will be divided. So V is equals to 2700 into 3.6 minus 22,000 multiplied by 2.4 divided by 2700 plus 22000. Okay, calculating the values, we get 0.906 meter per second. Okay, this is the final answer for both of them, and it can be rounded off to 0.91 meter per second. Okay, in question 3b, during the collision each truck experiences an impulse acting on it. Calculate the impulse that acts on the truck during the collision. Okay, we have to find the impulse. So impulse is equals to change in momentum. So for truck A, truck A, it can be 27,000 was its mass, and initial velocity was 3.6. Okay, minus, so impulse is basically final velocity minus initial velocity is the change in momentum. It's 0.91 minus 27,000 multiplied by 3.6, so the change is 7.27 10 raised to power 4. Okay, this is Newton second or kg meter per second. This is for the A. And for truck B, it will be 22,000 multiplied by 0.91 minus 22,000 multiplied by 2.4. You get the same answer because it's action and reaction. The amount of impulse exerted on A will be same as exerted on B. Okay, so you have the same value of impulse. And for the part B, two units we have to state. One unit is kg meter per second and the second unit is Newton second. Both are units for the impulse and both are correct. The truck come to stop after 3 minutes. Calculate the deceleration of the joint trucks. Okay, we have to find the deceleration. So for the deceleration, v minus u divided by t, we have initial velocity of okay, the truck come to stop. Okay, so final velocity is 0 and initial was the velocity that was after the collision. Okay, so after the collision velocity was 0.91 and time, this is in minutes, you have to convert it into seconds. So 3 into 60, that will give you in seconds. Okay, it's 180. So the answer is minus 5.1 10 raised to power minus 3 meter per second square. Okay, 3D. Explain why the truck stopped moving. Why it stopped moving? Because of the friction between wheels and track. Okay, make him stop. In question 4a, a shell of mass 30 gram is fired from the barrel of a rifle of mass is given with the momentum of this. State the total momentum of the rifle and the bullet before the rifle is fired and give a reason for your answer. Okay, before the rifle is fired. So before firing, bullet and gun are at rest. So initial momentum will also be, momentum is basically mv, so that will be 0 for both of them. Okay, so initial momentum is 0 for the gun and bullet both. Calculate the velocity of the shell just after the rifle is fired. Okay, we have to find the velocity of the bullet when it is fired. Okay, so we have to use law of conservation of momentum. So . Balki we have a shell of mass is fired from the barrel of the rifle. Okay, so with the momentum of this 36 kg meter per second. Okay, both will have initial momentum is zero for the gun and the bullet, both. The final momentum, the sum of the total momentum should also be zero. So the gun and bullet both will have a same momentum in the opposite direction after we fired. Okay, so 36 is the momentum. We have to use the equation P is equals to mv, so V is equals to P divided by V. So P is given, that is 36, and mass is 1.9. So 36 divided by, sorry, 1.9, we have to find the velocity of the shell. What is the mass of, okay, we have to use the mass of the shell. This is in grams, so we have to convert it into kg. 30 divided by 1000, that will be 0.03. Okay, so we have to use mass of the shell here, 0.03. So that will give you 1200 meter per second. Okay. Question 4c, continue to calculate for the movement just after the rifle has been fired. Use the principle of conservation of momentum and your answer to part A to state the total momentum of the rifle and the shell. Okay, so use principle of conservation. Okay, we have to calculate. So principle of conservation momentum is total momentum before firing must be equals to total momentum after firing. Okay, so total momentum before firing it was 0, so we can say that, let's solve it there, it is 0. So total momentum after cooling is momentum of bullet plus momentum of gun. So we can say that momentum of bullet will be equals to minus momentum of gun. So both will be equal and opposite in direction after firing. Okay, so in the part B we have to find total recoil. So I'm going to erase this. We have to find total recoil. So total recoil is, for second part, total recoil will be same. It will be momentum of bullet is equals to minus momentum of gun, or we can, so momentum of gun is basically the recoil. Okay, is momentum of recoil, that will be given, that is given 36 kg meter per second. Okay. Moving towards the next question, question 4. Calculate the average force. The shell has a momentum of 9.8 kg meter per second just before it hits the target. It takes 4 milliseconds for the bullet to stop with the target. Calculate the average force needed. Okay, so first of all we have change in momentum, 9.8 kg meter per second. It's change because after hitting it will be 0, so change will be 9.8. okay, so the time is 4.5 milliseconds, so it can be written as 4.5 divided by 1000 seconds. Okay, what we have to find force. So force will be equals to change in momentum divided by time. So change in momentum is 9.8, time is 4.5 divided by 1000, it will give you 2200 newtons. Okay, and the next question, question 5a, Until the second half of the 20th century, cars were designed as strong, rigid boxes. Okay, and which designer thought would perfect passenger in accident. In fact, although average speed were much slower than today, passengers were often very badly injured. Modern cars are designed with safety features including crumple zone. The crumple zone are at the front and the rear of car but do not include the passenger section. In a crash, the crumple zone is designed so that it deform and bend. This is shown in figure 1.1. Okay, so this front region is basically, this is a crumple zone. Okay, so what we have to do, we have to find the use of crumple zone, explain why the front rear cars are badly damaged during accident. Use your knowledge of momentum and impulse force to suggest why cars with the crumple zone protect the driver and passenger from serious injuries better than one which is a strong and a rigid box. Okay, so we have to give a reason why we use a crumple zone. Okay, because it's a detailed question we need to answer. Let's move toward the next page. Okay, so crumple zone crumple zone protect a driver from serious injury because number one reason is it reduce the force by increasing time of contact. Second, when the car stops, momentum is reduced to zero already. Okay, and as we know that F is equals to change in momentum divided by time, so increasing crumple zone increase the time of contact for momentum to change, that reduce the force. Okay, as force is inversely proportional to change in time, so that is the reason why it is used for the safety purpose. Okay, so this is the answer. Question 5b, another safety feature of the modern car is airbag. During a collision, airbag quickly inflate, filling the space between the driver and the steering wheel and the windscreen, as shown in the figure. This is the airbag they have shown. Okay, so two cars are crash tested to assess how much protection airbag provide in road traffic accident. Car A does not have airbags, while car B does. Car A mass is this, and car B mass is 1500 kg. Both cars have a driver of mass 70 kg, and both cars stop from initial speed of 30 meter per second. It means change in momentum is same because they have same masses. No, the masses of car are different. Passenger is same. Okay, so momentum change is different. At the moment of impact, the drivers are thrown forward, taking different amount of time to come to stop. The driver car A stop in 0.3 second to stop, while the driver of car B takes 0.7 second. Okay, so with the airbag, it will take more time to stop. This was with the airbag, this was without the airbag. Using this information, calculate the force which would be experienced by the driver due to the impact. Okay, so we have to use a simple relation of force, that is change in momentum divided by change in time. Okay, So for calculating part 1, the force is combined mass is for car A, mass is 1200 kg and 70 kg is the passenger. Okay, so mass is 1200 plus 70, that is mass, multiplied by its velocity. Okay, so velocity was initially 30 of both. Okay, and the final momentum is 0. It's 0 minus this, because change in momentum is basically its initial momentum minus final momentum. Okay, divided by the time is for the car A is 0.3, so 0.3, you get the answer 127,000 Newton units are given. For the driver B, it's change in momentum divided by time. Final momentum is 0 because after the crash the car will come to rest, minus initial momentum, it's mass into velocity. So mass is the mass of the car is 1500, and passenger mass is, we have to add the passenger mass multiply with the velocity was 30, divide the time is 0.7, so that will give you 67000 Newton. Okay, so force A is greater, force B is less. Why force B is less? Because there is greater time. Okay, use this information, deduce whether airbags are a necessary safety feature or not. Okay, so what we concluded from this, car B, it's a 3-mark question, so you have to write at least 3 points. Car B has larger mass but less force on the driver. First point. And we can say that airbag increase the impact time, so increasing impact time reduce the force experienced by passenger. So bags are necessary safety